And make a start. Hi, I am Craig Gower-Page. I am a data scientist at Roche. I predominantly work on R package development for our clinical programmers and our biostatisticians, but I also work on supporting our scientific compute environment, our main kind of analysis platform. And my presentation today is going to be looking at the incredibly exciting topic of data formats. This is introduction. And the reason why I want to talk about this is, or what the problem is that we're starting to see that less people are using SAS. And kind of this is a bit of a facetious way of me framing the real problem, which is that with the increased amount of or the diversification of the analytical languages being used is arising to a problem of how do we actually store and share data in a way that is accessible from all of these languages. And it's not just within our immediate kind of clinical programming team, so it's also our downstream stakeholders, so our epidemiology colleagues, our early development or clinical scientist colleagues. These people are all wanting more access to our data and again, bring in a wide diversity of programming languages that they want to use. And what we're seeing is without an agreement or a standardization, we're heading into these aspects where we may end up with proprietary formats such as RDS or Pickle, which aren't interoperable with other languages. Or more commonly, we're seeing people use what I want to refer as lowest common denominator formats, such as CSV or XPT, which is just kind of what we know is accessible regardless of its kind of more lower level properties or performance characteristics. So to address this at Roche, a while ago, we set out to do a bit of a review of what was available and kind of put forward a recommendation on what format we believe we should use internally for our internal data sharing. And this kind of presentation today wants to kind of go over what we covered and what our recommendation is in hopes that others may also adopt this as their standards. To kind of address an elephant in the room, though, a common thing that comes up is, well, why not just use a database? Like a dedicated database completely solves or sidesteps this issue. And honestly, if we could adopt this, it would definitely be our preferred solution or our way of kind of resolving this. But at least at Roche, and I'm assuming this is true for many other companies, it's not that simple. We have a lot of historic processes and workflows that are completely dependent on disk file formats. And so for the short and medium term, we kind of really do need a drop-in replacement to act instead of the old SAS7 BDAT files. But longer term, we are still looking at this, and it's something we would like to adopt or move to in a more long-term solution. But something to consider, if you can adopt this into your workflow, this would definitely be the recommended solution. So first of all, I want to kind of just quickly go over the file formats that we actually considered as part of our kind of a review. And it's all of these that are listed on the slide at the moment. And unfortunately, I don't have the time today to kind of do this justice, to really go through each one in detail and kind of go through its pros and cons and why we discounted or accepted it. So the gist of this presentation, I'm just going to focus on these ones here in blue instead. I wanted to call out, though, the next slide is going to have some kind of performance or benchmarking numbers, and we only did those numbers for the top two rows. The bottom two rows were kind of disregarded before the performance benchmarks for various reasons, namely either they were deemed as kind of not really the right tool for the job, or maybe a lack of client libraries to actually do our benchmarking on. But a lot of these formats have got all their distinct use cases, and if you are interested, please do message me. I'll be happy to talk more about it. But just to keep the slides down to a minimum, I'm only going to talk about these ones in blue today. Before I do show those performance benchmarks, I just want to talk briefly about what we actually value when we look at these formats. And I'm not going to say this is in order, though it's not, I guess, not far from the truth. The number one factor is definitely client library availability. Like data sharing, data exchangeability are huge features that we want to be promoting. So a format having a large array of languages that it supports is definitely a major plus point for us. And at the same time, we kind of started to value a lot more having actually like explicit data typings. Like historically with SAS and XPT, there are kind of only two data types, your numeric and character, with most other data types being implicit based on some sort of metadata or derived from it. We kind of more valued formats that had explicit typing available so that the data could actually be more kind of self-contained or have a bit more semantic meaning to it. Likewise, a lot of people will argue performance isn't the most important thing. Like we've largely in our kind of area of work deal with small to medium-sized data sets, but we still do care deeply about performance because it does massively impact people's user experience. If you can reduce someone's wait time from a minute to seconds for loading a data set, that does improve your developer productivity and the quality of life whilst they're working. So these are important factors for us. Also integrations, this kind of means what sort of tooling or third-party support is available, what other tools are available that can make use of this format out of the box with little additional manipulation or changes needed. And finally, whilst storage is kind of really cheap in comparison to the cost of trials, we are still conscious of file sizes. We don't want to be having to pay for storage unnecessarily or be bloating our disks if we don't have to. So file size, although probably the lower of the importance factors, is still up there, something we consider. So moving on to some performance benchmarks numbers. I'm not going to go through all of these explicitly, but just to kind of explain what's going on here is we created a data set that was kind of 1 million rows with 34 columns of various different types. And then we used the R client libraries to kind of read and write those data sets to get a feel for what their performance kind of times were. I think the major standouts here in terms of the negative would probably be JSON and kind of XPT, which kind of really did not perform well from a pure performance viewpoint, with JSON being the worst in every category and XPT not being too far behind. And then on the other end of the extreme, DuckDB, Feather, and Parquet are really promising formats in most regards, which is kind of why I'm focusing on those ones in terms of what to talk about next. So deep diving a little bit, I want to talk a bit more about JSON because I think given the kind of ongoing CDisk dataset JSON project, I think some people are kind of beginning to consider using this as their de facto standard. But in our kind of testing and evaluation, we really struggled to recommend it for our internal data usage. In particular, as shown, it's got kind of really poor performance characteristics. Its data typings are relatively limited. It supports kind of some of the fundamental stuff, but there is no inbuilt support for dates or times or categoricals. In fact, if you're kind of using JSON in general, you really need a schema to go along with it to kind of give semantics to the data, which essentially is what dataset JSON is. It's kind of a big schema to JSON to say how to interpret that data. The problem is if you're having such a schema, it kind of undermines the ubiquity argument of JSON because you can no longer just rely on the language parsers, which most languages have. You need something to be able to also interpret or convert that JSON from the scheme, from the format it's in, into an actual tabular data set in your language, which means that if you are going for dataset JSON, you need to ensure that the parsers are available for your language, which isn't always a given. So from that angle, it's not one we recommended for internal usage. Likewise, just because I believe this is probably the epitome of the lowest common denominator format, we weren't overly keen on XPT. It's, again, has relatively poor performance, very limited data typings, and kind of has a lot of legacy properties that are well known that come with it, like the lack of support for missing character or 8-byte variable names. That being said, there's some pros for it is the fact that most statistical programming languages do have support of it, and we do have a lot of within industry tooling that also uses it. However, we felt this just wasn't quite good enough, or we wanted more from the format that we use for our internal usage. Going into the more positive end of things, I kind of wanted to raise DuckDB as our kind of runner-up format, which kind of impressed us a lot. It has really good, sorry, It has really good performance characteristics, really small file sizes, lots of explicit typings, and lots of client availability for lots of different programming languages. In fact, the only reason we kind of didn't select it as the time for our internal format was that when we kind of did this exercise over a year ago, it hadn't yet had its 1.0 release, and we didn't feel quite comfortable given how new the format is. But it's something we're definitely keeping an eye on, and we're really interested to see how it evolves and how it performs when it gets a bit more battle tested, because it's definitely a very interesting format for many reasons. The only thing is mentioned there is it does have an ODBC connector as well. So for languages that don't have a direct client library, they can make use of the ODBC connector. However, in our internal testing, we couldn't quite get it to work for Sass, though I should probably say I suspect this is more about how we've internally set up our servers rather than an actual issue with the ODBC connector itself. But yeah, a really promising format that we plan to keep an eye on. And finally, we're now moving on to the format we did actually end up going with or selecting, which is the Apache Parquet format. This is a columnar data format specifically designed for storing tabular data for analytic processes. This is literally what it's been designed and built for, and it's very good at that. So just going into the pros and cons list, it kind of ticks most boxes, really. Amazing performance, small file sizes, lots of different data types that it supports, great client library availability. The only kind of real big con to be aware of is that the Sass client library is currently locked behind Sass Via, which I think quite a few companies haven't yet bought into. They're still on the old version 9 version of Sass, which can be an issue. For us, we kind of sidestep this issue by developing an internal read Parquet macro that simply converts Parquet to XPT on the fly and gets Sass to read in that XPT file, which isn't ideal, but it's just kind of a way of bringing Sass to the party as well without having to necessarily upgrade our Sass installation. I've also listed supports arbitrary metadata in both the positive and the cons, because it does support metadata, which everyone loves and always get asked about labels, and it does support that. But because it's arbitrary and not structured, some of the client libraries store it in a way that's not accessible from other client libraries. So for example, labels written in R aren't automatically made available to Python. So you'd have to kind of do more explicit metadata setting if that is a feature that you're interested in. One thing I do want to talk about is kind of this distinction. You'll probably hear people refer to Parquet as Arrow or Feather, or use these terms interchangeably. They are separate entities, but they are highly related. And the best way to think about this is Parquet is kind of your on-disk storage format. And that's different to Arrow. I list the types here in particular to try and really emphasize the fact they are different formats. Arrow is the kind of in-memory format. So a lot of the client libraries for Parquet, when they read the data from disk into memory, they convert it and store it in memory as the Arrow format. And where Feather fits into this is Feather is then just a dumping of that Arrow memory to disk, which kind of then skips that Parquet conversion step. And this is why Feather kind of has some better performance characteristics at the cost of then missing out on some of the features or the compression that you get with Parquet. But by and large, like the Arrow project has written a lot of the client libraries for Parquet. So whenever you read in Parquet, you get this kind of automatic translation. To be honest, this is more in the background. This is kind of just for awareness that if you want to be lazy, you can kind of see these things as interchangeable, but that's not strictly true. Running out of time a little bit, but I just want to talk briefly again about the integrations, because this is where some of kind of the power of Parquet really comes in. What I'm showing here is a screenshot of a tool called dbeaver, which is kind of a database viewer, but this has extensions that allows it to read in Parquet datasets directly. So here I'm able to use dbeaver to actually explore a Parquet dataset interactively and make use of all of the DB features, such as kind of calculating group columns or counts, or just generating summary statistics on the fly. It's just a way of interactively exploring your data. And at the bottom there, I've just done a big dump of all the different tools that I could find that have direct support or integration with Parquet. This is one of the real reasons that we really are promoting this format internally, is that so it just maximizes the ability for other people to come and use our data. And final thing I want to talk about is just some advanced features of Parquet, which is its direct integration with dplyr, alongside its ability to have predicate pushdown and projection, which is basically sorry, 1 second. Sorry, which is just a fancy way of saying it's able to kind of select what data it wants to read from the data set and only read those elements into memory. So instead of, if you have a 2 GB file, it maybe you only actually need to read in 200 megabytes into memory. And this allows for the format to be incredibly performant when you're only dealing with a subset of the data actually stored. And all of these features are directly supported in the dplyr syntax as shown here. So it's at least from an R user's perspective, it's a very friendly, easy to use format. So in summary, the problem we're facing is that this increasing diversity of languages means that we're risking kind of data lock-in or a use of lower common denominator storage formats. And to combat this, we at least internally are recommending our teams to adopt or store their data as Apache Parquet in order to try and avoid these problems and to promote data sharing and allow other languages to all be involved in a single project. I just want to say this has been a complete whistle-stop tour. This is quite an involved, in-depth subject. So if you are interested in more details or want to discuss more, please do ask a question or let me know. I'll always be happy to talk about it. And thank you for listening. Any questions?